Welcome. Here we have a sequence that's a little strange looking. It don't seem to always increase. It don't seem to always decrease. And our task is to find the next terms. Uh, find the pattern and see what we can say about any future terms in this sequence. So we look at it and what what is going on here? Okay, so can you find the next term? Or better put, can we find the next terms? 3, 7, 28, 24, 6, 10, 40, 36, and 9. Well, you certainly, if we add, subtract, multiply, or divide, uh, just doing one thing, you're either going to be increasing or decreasing. There's going to be a problem. This one goes up, it goes down. I see two prime numbers, but only two. So, um, so if we look at the first two numbers, we got two choices here. We can add 4, or perhaps something with prime numbers, like every second prime number, 3 and 7. So we consider those things. Uh, Even if you look at Fibonacci, it's adding 3 and 7 is not equal to 28. So there's a problem with just about anything you can think of. So let's see. We can add 4. Yeah, but what's that going to do? There are no other primes here, so we're going to disregard anything to do with primes. Now, it is possible to do primes plus 1 or primes plus 2, but the primes always increase as we go through a number system. We don't go back down. So um, maybe there's more than one port. So let's see if we can add 4 anywhere else. Well, what is 6 plus 4? Well, there's 10. So I have maybe a start, maybe every two numbers are doing something. So here I have adding 4. Let's see. Let's look at the blue numbers, the ones that we didn't consider. Oh, let's try subtracting 4. 28 minus 4, 24. 40 minus 4, 36. But how did we get the 9 here? And even if I can fill in one more term, then what would I do? So getting from the red numbers to the blue numbers, or the blue numbers to the red numbers, that still begs the question, how? So I can look at this as two uh, sequences, one embedded in the other, but how do I get to the next pair? I can see what happens in the next pair, but I have to have a way of getting there. So I got to be able to get from the red to the blue to the red again, and then back to the blue. So I can figure out what the next pairs might be. So let's take a look. It looks promising, but how do we get from red numbers to blue numbers? Well, we could just say we were given the first 4 numbers, but is that really reasonable? Uh, if I were given these 4, I still don't know how to get to the next pairs. And so even given the next 4, the first 4, and I can figure out the pattern, I don't know how to get to the next pair. So that's not only not reasonable, but it's rather useless. So uh, Let's look at the 7 and the 28. Take a look at that pair. And the 10 and the 40, getting from reds to blues. How is 7 related to 28? Well, so far we have used the number 4, so it's reasonable to continue to do so. At least we'll give it a try. So if I want to get from 7 to 28 using 4 and see if the same operation gets me from 10 to 40. What is 7 times 4? Well, that's 28. And what is 10 times 4? Well, that is 40. So we now know that we can get from the reds to the blues by multiplying. So by the same number. So this sequence seems the key on the number 4. So we add, multiply, do something, and subtract. Well, we got to figure out what the do something is. So we're left with getting from the blue number to the red number. 24 and 6, 36 and 9. So how are we going to do that? Well, we still have to try something, and we've so far worked with 4. And there is one missing arithmetic operation, and that's division. So what is 24 divided by 6? I'm sorry, yeah, 24 divided by 4 is 6. And what is 36 divided by 4? Oh, look, it's 9. And so I colored the 9 in red because it will be part of the pattern where the next number should be adding 4. So we figured out the pattern. It's based on the 4 arithmetic operations: addition, multiplication, subtraction, division, in order. And it's based on the number 4. So it actually works. Can we find the next terms? Well, 9 plus 4 is 13. So the next number goes here is 13. 13 times 4 is 52. 52 minus 4 is 48. And 48 divided by 4 is 12. And you can continue this on and on as far as you might want. So this is a fun little pattern. It doesn't have to be based on 4. You can write your own and base it on 5 or base it on 7. The first time I encountered this, it was based on the number 3. It doesn't really matter where you start. And you don't have to start with 3. And I just picked an arbitrary number to start this. You can start anywhere. Well, thank you for watching, and please consider subscribing to the channel. There are many other videos, and some are into calculus, and some are simple, and there's a lot of algebra. It's a pretty good range of math, so I appreciate if you would give that some consideration. Thank you.